are going to continue to solve quadratic equations using multiple methods. Let's talk about this really quick. Actually, I think before I start this, guys, I am going to talk about some vocabulary. Okay, so we've been talking about if this was plus or minus 2i, x equals plus or minus 2i. We've been calling these complex roots, right? But this is actually not a complex root. This is an imaginary root, okay? So where would this imaginary root be? Where would the axis of symmetry be? Can you tell me? At 0, because there's nothing in front of the plus or minus, right? So it would be at 0. Where would the vertex be? On the axis of symmetry, but where? There's a clue here. One, two, three, 4. Why 4? Two squared, right? Because that's that distance, right? But since it has I, we know it's imaginary. So normally it would be 4 without the I, right? And the I makes it imaginary so that it doesn't ever cross the x-axis. Okay, that being said, if I change this to, I know what I'm going to do. I'm going to change the axis of symmetry on you and see if you can tell me what it would be. Let's make this one. Can you tell me what those roots would look like? If this root gives me this, if I give you this, can you tell me what this would be? I've got 2 hands. I want to see more than that. 3 hands. Okay, I think Kayla's hand went up first. You want to tell me? Almost. Tristan, you want to add to that? 1, 2, 3, 4, 5, 6. Right? Because this is your axis of symmetry, and then this tells you where you go up or down your axis of symmetry to find your vertex, right? Okay. Now I'm going to take it one step further. So let's look at this one. So if these are my roots, wouldn't I say x equals positive 2i and x equals negative 2i? If I would subtract that, wouldn't I get x minus 2i equals 0 and x plus 2i equals 0? So if I want to find my quadratic equation, I should have grabbed that. Oops. Don't want to do that. I'm probably going to do the other one over here. So x minus 2i and x plus 2i equals 0, right? If that equals 0 and that equals 0, then when I multiply them by each other, they also equal 0. So x times x is x squared. This is a positive, sorry, negative, and this one's a positive, so they're going to cancel each other out anyways. The difference of 2 squares. And this, 2i times 2i, is 2i squared equals 0. So I have x squared minus 2 squared I squared, which is I squared is negative 1, which is positive 2. So every time you see, sorry, it should be 4. Sorry, thank you. I was just, you know how I caught it? Because it should be a square. So every time you see 2 squares and there's a plus sign, that means it must be imaginary, right? Let's look at this. So what if I had x squared plus 16? What do you think my roots would be? Plus or minus 4 what? I. You know how I would do it? Algebraically, I'd move the 16 to the other side, and it would be negative 16, and when I took the square root, it would be a negative underneath there. That's how you do that algebraically. See how those all come together now? See how much you've learned? Okay, so why don't I have everybody looking up? All right, so I'm going to come back at the end. And do you want me to just do that one real quick for you and how it's different? Okay. So let me take a picture of it. Since we're already on this, I might as well. Because there was one on your quiz, group quiz like that, right? It was a bonus question. All right, so I'm going to do the same exact thing. I'm going to look at them separately. 7 plus 3i, and x equals 7 minus 3i. If I were to subtract everything, so I have a 0 on one side, it would be x minus 7 minus 3i equals 0. And this one would be x minus 7 plus 3i equals 0. Now I'm going to put them together. X minus 7 minus 3i, x minus 7 plus 3i equals 0. And if you notice, these two match. This is the only part right here that's actually the plus and minus part. So I'm going to put them both in squares. So x minus 7 goes in a square, and 3i goes in a square. I can FOIL this in my head because it's a perfect square trinomial, so it's x squared. 7 squared is 49. What goes in here? If you were to look at it, wouldn't it be a negative 7 and a negative 7? I just did the opposite of completing the square in my head, right? Because wouldn't I take half of 14, which is 7, and square it to get that, right? And then minus 3 squared and I squared, which makes x squared minus 14x. I kept putting the 0 on that side. I should do it on that side. Plus 49 minus 9 times negative 1. So if this is going to be positive 9, and 49 plus 9 is how much? 58. And that's my quadratic equation for that one, for these groups. Yes. That's what I'm doing. That's exactly what I'm doing. I'm saying negative 7 and a negative 7 make a negative 14. Yes. what if you were to square negative 3, you get positive 9? Say it one more time. Because I'm not squaring negative 3, I'm squaring 3i. The negative's in front of it. Sorry. Took me a while to understand what you were saying. So this is negative, and this makes it positive. Okay, let's move on. All right, so with clickers, Miss Liz's class was a little confused at first. They tried to use the quadratic formula or complete the square or factor. And do I need to do any of that for this? No, all I'm looking at is the discriminant. I want to know how many roots it has. So let's do that. So if b squared minus 4ac is bigger than 0, how many roots am I going to have? 2, because I start at the axis of symmetry, and I'm either going to go this way or this way, depending on whatever's underneath that square root, right? What if it's 0? 1 root. What if it's smaller than 0? 2 imaginary or complex roots, right? Oh, that's what I meant to do with this one. So the vocabulary. All right, so these are imaginary roots. This is actually a complex root. And the difference between the two is that this is not an imaginary number. This is an imaginary number. This is a real number. So when I have real and imaginary put together, we call them complex. So I didn't tell you that originally because it probably wouldn't have made that much sense and you probably wouldn't have even cared, right? But now that we've been through all of it, do you understand how there's difference? So this is purely imaginary root, and this is a complex root because it's got an imaginary piece and a real piece. And we call this, when we talk about all of them together, under the umbrella of complex numbers, because we're talking about real numbers and imaginary numbers together, so we're talking about complex numbers. Okay? All right. So put this one in your clicker. Well, either none, 1, or 2, please. 1. Okay, we've got some confusion, right? Those bars don't look very good. All right, let's change this. Cover up my pretty picture. Okay, so I have b squared minus 4ac. My b is 8. Oh, I know where the confusion is. My a is 6, but my c is not 12, because this is not set to 0. So if I subtract 3 from both sides, this is actually 9. Right? So then I get 64, and as long as this number is bigger than 64, this is going to be imaginary roots, right? So I may not know what 24 times 9 is, but I know what 24 times 10 is. It's 240. That means it's going to be a big number, right? So I don't even need to do any more, right? It's going to be negative. That is going to be no roots or imaginary roots. That is A. Okay, one more? Are we good? One more? Got it. Look at my pretty picture. So here's one. When it's greater than 0, it's 2 roots. When it's less than 0, it's no roots. And when it's 0, it's 1 root. Do that one for me. I'm going to start your clickers. $20 seconds.
I'm done. I got it. Huzzah.
Okay, you guys did better on that one. Most of you said B. B is correct. So if I have b squared minus 4ac, my b is negative 2, my a is 1, and my c is not negative 9, but if I add 10 to both sides, it's going to be 1. So this is 4 minus 4, which is 0. Okay, moving on. All right. I put these graphs up here. I'm curious. You guys tell me, which one do you think it is? Just by looking at this. I can give you 10 seconds to pick. That's what clickers are for. Which graph do you think it is? Most of you said C. All right, let's take a look at it. Let me change my color. Okay, first of all, it's a negative. That means it's got to be pointing down, right? And it's the only one pointing down. That was the easiest one ever. What's the other thing I can check? The y-intercept. Is it at -7? It sure is. What about this? Which one would you use? Which would be the most logical? Most logical for you to use. Hold on. That's what clickers are for. Most logical. Pick A, B, C, or D. Wow. A, C, D.
What is it? What is it? Color.
Okay, for this particular one, well, let me do it. What do you think I'm going to pick? Why would I complete the square on this one?
It's not that much.
There's a couple different ways to do this. Okay, so I'm going to go ahead and complete the square. So I'm going to add 7 to both sides first, and so I would have this negative. Let me just cover this up, and then I can use this space right here. There we go. I don't want to cover up my pretty pictures. Okay. I just lost my pen. Okay, too much side chatter for my liking. Okay, so if this is 0, right, we're not going to talk about it graphically anymore. We're going to talk about an equation, right? So if I have add 7 to both sides, I would get negative 2x squared minus 8x equals positive 7. I'm going to take a negative 2 out on this side, and I would be left with x squared plus 4x. And if I want to keep going, I would add something to make it a perfect square trinomial. And if I do that, I'm going to have to add something to the other side. But what did I forget? What did I forget if I have to add something to both sides? Amanda. If I have to add something to both sides, what did I forget? Yes. It's not just adding this, I'm multiplying it twice, right? But not just twice, negative 2. So I'm going to change this to a negative 2. Why? Okay, now, remember when we did this before, now forget about the negative. If I had 2x squared, hold on, let me finish. If I had 2x squared, wouldn't I split them up? Right? And if I had 4 x's, originally I had 8 x's, right? But I split them up. So it's 4 x's and 4 x's made to 8 x's. Now when I complete the square, what number is this going to be? Because when I take half of 4 and square it, I'm going to get 2 squared. correct, guys? Well, isn't that 2 squared, what I did right here, 2 squared? And over here it's going to be 2 squared. So, Philip, do you see? I have 4 2 times. There's 2 sets of 4s here. Why is it negative? It's negative because it was originally negative. So I pulled a negative 2x out. I'm multiplying. No. It's 7. No, minus 2 times 2 squared. It's the same thing, guys. It doesn't matter which way you look at it. If I take 2 squared, please stop talking. If I take 2 squared, which is 4, times 2, which is 8, and say 8, isn't that the same thing as saying 2 squared, which is 4, times negative 2, which is negative 8? They're the same thing, right? Because order of operations says I have to do the squaring first, which is 2 squared. Then I have to multiply, which is 4, right, sorry, 8, and then 7 minus 8. Okay, so we're going really slow on this one just because it's kind of like a review. All right, so now I have negative 2 times x plus 2 squared equals 7 minus 8, which is negative 2 times x plus 2 squared, which is negative 1. But then when I divide both sides by negative 2, I'm going to get x plus 2 squared equals 1/2. Nope, negative 2 divided by negative 1 makes positive 1/2. Then I'm going to take the square root of both sides. And I'm going to get x plus 2 equals plus or minus root 1 over root 2. I'm going to split them up. Negative 2 plus or minus root 1. 1 is always squared, right? So I get 1 over root 2. Now, this is the answer you get if you completed the square. The answer you would get if you did quadratic formula would have been rationalizing the denominator. I would get root 2 times root 2 is positive 2. You would get this. They are the same thing. This and this are the same thing. Yes. Yes, exactly. It all ties together. There's one more way I could have done this that's even kind of a little bit easier, and then I'll come to questions. You ready for this? Are you ready for this? In this step right here, check this out. Guys, I need your attention. Is it? Okay, guys. Squirrel. In the very beginning, if I wanted to get rid of that, couldn't I just divide everybody by negative 2? Couldn't I? Is that equivalent? The chatting needs to stop, please. I've asked several times. Negative 8 divided by negative 2 is positive 4x equals negative 7/2. Now you're dealing with a fraction, but let's see if it gets any easier by doing this. Do you guys see what I did? Aren't I allowed? I could multiply everybody by 1,000 if I wanted to, and it would be equivalent, as long as you do it to everybody. So I divided by negative 2 to everybody. So completing the square with this is a breeze, right? So if I complete the square with this, I get x squared plus 4x plus something equals negative 7/2 plus something. So this is, my something is 2 squared, or 4. So I get x plus 2 squared equals negative 7/2 Well, how do I make a 4 to have a denominator of 2? What does my 4 need to be in order to have a denominator of 2? 8. You just multiply it by it, right? Because 8 divided by 2 is 4. What's negative 7/8 and 1/8? I'm sorry, negative 7 over 2 plus 8 over 2. Negative 7, 1/2. Isn't that exactly what I had over here? Isn't that exactly what I had here? Do you see how much faster I got there? Okay, let's do one more. But I want you guys to do this one. So on this one, what would you do to make that an easier problem?